Hello, my name is Brian, and I'm going to be doing some hacking on Tiger Beetle. Thanks for joining me. This is going to be the third stream I've done hacking on the Tiger Beetle Rust client. If you don't know, Tiger Beetle is a financial database that's super fast. It's got clients for a bunch of languages that you might want to use, and doesn't have one for Rust. And eventually we need one for Rust. So I am working on a Rust Tiger Beetle client and doing the whole thing on stream. I've done 2 streams so far if you've already seen it, and we've only got a little progress, and today we got to make some progress, get stuff done. So far, let's see if I want to make sure everything's working here, and then I'll talk about what we've accomplished thus far. Looks like everything's going well. I can hear myself. Okay, so this Rust client for Tiger Beetle that we're making, it's going to be, there's a couple ways to write a Rust client. So in Tiger Beetle, there's a canonical client written in Zig that supposes a C FFI. And all of the Tiger Beetle clients so far use this FFI bindings to the Zig Tiger Beetle client. For various reasons that I don't remember anymore in Rust, we eventually want to have a pure Rust client, but that's kind of the hard way to do it. And so to start with, I'm writing Rust bindings to the Zig Tiger Beetle client. And going to get that mostly done, and then we'll write a second client that hopefully conforms to the same interface that is written in pure Rust. And eventually we'll be able to kind of like pit them against each other and test to make sure they behave the same way so that the pure Rust implementation behaves like the canonical Zig implementation of the Tiger Beetle client. Now, so far we have done only a little bit. We've set up our Rust project. We learned to build the static C Tiger Beetle client library and set up a Rust build script to link it to the Rust library. Then we used BindGen, the Rust program for generating FFI bindings, to automatically generate Rust definitions of the TB client Zig library. And then we wrote a little bit of code to kind of sketch out the API we're imagining that kind of corresponds like a Rust correspondence to the TB client FFI. And a little test program to just try to run some basic initialization of the Tiger Beetle client. And on the last stream, we ended up with a little test program that calls the Tiger Beetle client's init function and then immediately crashes. So that was a good progress for them. But today, we really need to start making progress. And what I think I want to do is try to push forward this code that calls into the Tiger Beetle client and get it so that it is doing some actual useful work, calling through the client FFI and over the network into the server, and actually doing stuff. It'll be kind of like exploratory programming today. I'm expecting that everything we write today will be kind of prototype quality, not necessarily keepers, but I want to get to a point where I understand how the TB client works. And then once I understand how the TB client works, I'm hoping I'll get an idea of how the Rust async API is going to like live on top of the TB client. Because as we'll see, the TB client is pretty basic and isn't really obviously how it works async. And I kind of need to just like experience the TB client, how it behaves and how you program against it to kind of understand where I want to go with the Rust client. All right, and I see, hey, Nictor in chat. Good to see you here hanging out with us. If you're expecting MattClad, I am not MattClad, I'm Brian. The name of our Twitch stream is something like Iron Beetle with MattClad, but sometimes it's not MattClad, sometimes it's Brian. We're working on the Rust client for Tiger Beetle today. All right, let me go switch over to our code and just refresh where we are. It's pretty much every time I sit down, I gotta take a few step backs and figure out what's going on. right, so here's our branch here. We're on a Rust client branch. That's the right branch. And our commits are just 3 commits here of junk. Usually when I'm working, I don't really think too hard about the commits, but I do want to kind of, interesting that I started on this branch. Huh. Anyway, I kind of want to consolidate these 3 junk commits into 1 commit right now. So I'm going to, oops, don't know what I just did there. I'm going to say git reset and reset it a few steps back, and then just amend this commit. And I want to, if we recall from previously, we're binding to the Tiger Beetle client, TB client static library, and we don't have the build set up to automatically build both the C side and the Rust side at once. So to build the static library, we got to issue a command before we start even getting developing. And the way we do that in the Tiger Beetle build system is clients:C, I think. I think that'll output, and I'm wrong. Oh, you gotta say zig build. So zig build runs, your zig build script. And then clients:C is just the name of our build target. And let's refresh our memory of what that even does. It's going to output some libraries to source lib, maybe? Nope. What's in source clients? So ls source clients. Then under here, there should be, under the C client, some library that contains a bunch of static libraries. Okay, here they are. And of course, Zig is a very capable cross-compiler, so it just output all of our potential target libraries for us. And they're all in these directories. I'm not going to dig into them, just kind of remembering. Now, if we go into the Rust directory, which is source clients Rust, I think, we should be able to say cargo build, and that should link to that static library. And then we can even kind of go run our test program, and it should just crash like previously. All right. So here's a stack trace that you can see it's tracing through some Rust code and then some Zig code. And, the Zig client is not happy because I didn't pass it the right arguments. And that is interesting. I have stuff here that is not checked in. Is that true? Can I possibly have failed to check in stuff here? Well, I'm glad it's still here in my workspace. That's fortunate. Let's see what it is. Okay, so one of these, TB client, is generated code. And I actually don't want to check that in. I want to make that get ignored. So I'm going to just reset and rethink about what I'm doing. And I want to say git diff clients. I want to see what's in main. This is a little test program. It doesn't do much. I don't remember how to diff this offhand. Oh, it's not checked in, so there's no diff. Source, main. Okay, it does almost nothing. Just pass some bogus arguments to our placeholder client that doesn't really work yet. And this TB client, we can go ahead and look at that over here. Tiger Beetle clients, nope, source clients, Rust source, something. This is all generated code. And I'm outputting this in the source directory so that it's easy to find and look at for reference. But it's generated at build time by the Rust build script, this thing here that we did in a previous stream. All right, and I have a git ignore here specifically for, that's for all the clients. I have a git ignore just for the Rust client. And here I can say git ignore source tb client.rs. And that way we don't check in our generated Rust code. And again, I don't care about our history now. I'm just going to amend this. And I'm going to push this because I almost lost this code before. I don't want to lose it now. I think I can git push. There's probably not a tracking branch. Let's see. git push, no, git push Burson. My name is Burson on GitHub. If you want to check out my stuff. And we got a force push because we just rewrote history. Okay, so now we have caught up and figured out where we were last time. And that was a week ago. So the first thing I want to do, usually the first thing I do is just going to rebase and make sure we don't fall behind the main branch. So I'm going to fetch, I think, origin. I'm going to say git rebase origin main. Shouldn't expect any real conflicts here, but we need to rebuild our client. Zig, oh, I'm in the wrong directory. Zig build our client. And then we can go change directory and, run our Rust again and make sure nothing is broken. Source clients Rust, cargo run. Okay, so now we have caught up to where we were and we've rebased. And the next thing I want to do is go look at our code for our library and figure out what we want to do. So the thing I want to do today is I want to call some functions and get it doing some real work. And I don't know how to use TB client. I haven't used it before. I just kind of looked at the APIs and I've sketched out some Rust APIs here. You can see these Rust APIs do very little inside this init function, which corresponds to a init function in the Rust or in the C FFI code. Here's the corresponding Rust code here. I can go look for init function, TB client init. And we're also probably going to want to look at the C header code for reference. The Rust, while we're working on our calling this FFI, we have several sources of truth we can look at for how we call the API. Here's the Rust bindings. These are auto-generated. It's mostly readable, but this should correspond very directly to the C definitions. And I'll go find those now. tbclient.h. This is also generated code. This is generated by the Zig build. And there's another bit of code somewhere. tbclient.zig is not it, I think. I think this is actually, no, this might be, this is actually the implementation of the TB client in Zig. We might need this at some point, but it doesn't correspond directly to the API we're writing to. So when we need to kind of look at what's actually going on under the hood, this file is probably useful. There's another one though, TB client header, I think is the generator code. And I think this generates tbclient.h. And there's another piece of code somewhere that corresponds more closely to tbclient.h. And I'm wondering if I want to try to find it. Yes, the generator again, or if I'm just gonna suffer through without finding that. TB client exports could be it. This is it. So tbclient.h is calling, or is creating C definitions that correspond to these exports in tbclient exports.zig. So as we work on our Rust bindings, we're going to be cross-referencing at least 4 different files here. The C header file, which is auto-generated from Zig code, the Zig client code, which is tbclient.zig, and also that list of exports in Zig. So there's already a lot to keep in mind here as we go forward. And then finally, we want to look at our Rust client test program. So this main.rs is just a program that calls our Rust library. And eventually this is going to be used as a bit of a test harness, because Tiger Beetle has a program in development called Vortex, I think, that is going to want to be able to test the Rust client through some executable. And this main program will eventually be adapted for that purpose. But for now, it's just kind of like our manual test bed for our prototyping as we're learning how to develop this client. And so what we're going to do today is write this and start passing sensible arguments into init, fill out this init function so that it calls the TB client correctly and get this client initialized correctly. That's kind of our first step. All right, so this init function in our Rust client, which is called Zig client, a little confusingly. But this is the Rust client that we're kind of creating an API for right now. Has a cluster ID. And I'm going to go ahead and define all these things as locals, just so we can read them better on stream, basically. And then we're going to pass these in and wire them all up. Address, on completion context, you can see here. So as I've talked about previously, I don't know what this does. On completion is a callback, which here I have not defined the correct type for. On completion context is just a number, probably for doing dispatch in the callback. And I haven't, we're going to have to figure that out soon. So I say on completion context, we're going to give this a value of 1, so just a different magic number from the cluster ID in case we see it like in a debug message or a crash message at some point. And on completion, right now it's defined as nil, but eventually it will be defined as something sensible. And a lot of our initial work here is going to be just figuring out how to do just the conversion from Rust types to CFFI types. It's going to be a little tedious for a while. So we have a cluster ID, address, especially that string. I bet it's going to take me 30 minutes to remember how to convert the Rust string to a C string. At least it's just a string though. So I was really worried before this stream that this was going to be like an array of C strings we had to get a hold of here. And that was going to take a lot of doc reading on stream to figure out how to do that. All right, on completion context and on completion. On completion. And this returns a result. So I think probably what I want to go ahead and do is set up some kind of error handling here. Well, let's get this to build first, and then we'll checkpoint ourselves and set up some error handling. Cargo check. I'm not sure if my check here is checking the binary or the library. I think it'll probably check both. Let's just do a build just to see. Okay. That's not worth running. We just want to make sure it builds. And then we'll set up some basic error handling. I'm going to use the anyhow crate. Anytime I want to do simple error handling but not think about it in Rust, I use the anyhow crate. And we can just say cargo add anyhow. And I'm thinking about whether I want to use anyhow in the library or just this test binary. And actually in cargo, I think I can't distinguish. I think I just have to say this is a dependency of both the library and the binary. I don't think that's distinguishable in cargo, but I'm going to say cargo add anyhow. And then if we look at our manifest, we now have dependency on anyhow. And up here, we can say use anyhow result. And here we can have main return a result of nothing, of nil. And then in it, we can just put a question mark. And now we're doing error handling if we get things to build. Standard error is not satisfied. Oh, why is that? I bet yeah, okay. So here's what's going on. I'll show the error here. The question mark type, or the question mark in Rust says, if I receive a result of an error type, then I can propagate that error type up the stack. And my anyhow type that I just added is properly implementing the error trait in Rust. But what I didn't think about here is that when I set up the library, I made init return this binding to TB status as the error type. And TB status is just an integer. We can go look at our tbclient.rs, TB status. It's just an integer. It's not a proper Rust error type. So to make this an error type, we're going to need to wrap it in some kind of error and make it a proper error type. And now I'm thinking, do I want to do that now or just punt this in some way? And I think what I will do is I'll go ahead and wrap this in an error type, which is kind of a pain, but it's got to be done eventually. Let's do some yak shaving. So to do this, we're going to use a different error library because we want our library to do, have proper static error types, not just any dynamic error types. So the anyhow error is just saying like, here's an existential error. I can't tell you exactly what type this error is. I just got errors. Errors and errors, errors. It could be any kind of error. But for a library, you don't really want to be just saying, here's some error. You want to be more specific about the errors you return. And I think as of now, probably the easiest thing to do is just make a proper error type. So to do that, I'm going to use the get this error crate. So I'm going to say cargo add this error. And we can go look at our manifest. Probably don't need to show you the manifest every type, but now we have another dependency on this error. And then within our library, and again, I know this code looks just hideous right now, but we're in an exploratory phase, so I don't really care too much. I'm going to say use this error. Error? I'm not entirely sure, actually. I might have to read the docs for this error. And up here, I'm going to say pub enum status error. It's just going to be a wrapper around that status type for now. Eventually, we might have to create other error types like that are more rusty, but right now we're just going to wrap that uint. And in that case, it probably doesn't need to be a status error. I can probably just say pub tb client tb status. And then on here, I can just derive what I need from this error. I'm going to say derive, probably error, debug, read the docs for this error is probably the next step. We'll build this, but it's probably going to fail. I want to go read this error docs. Oh, okay, so status error cannot be formatted with the default formatter. That's fine. There's an annotation used by Derive that can make this format correctly. Like I have to put something here. And usually with this error, you're creating an enum for your errors. But in this case, it's just wrapping, it's a single type of error that wraps it in int. So I'm using a struct. And probably there's something I have to write right here to say, here's how to implement display. Because as you can see, our error message just is saying, we don't implement display. So let's go make a trip over to the internet and look up docs.rs, this error. And it is probably going to be something very similar to this, or even like this. But again, look, this is an enum, which is the common way to define an error in Rust, but we got a struct. So it's going to be something like this, but we got to place it somewhere else because we don't have a enum variant to put this attribute on. But I'm just going to go guess where this goes, and we'll see if I can guess correctly. And if not, we'll have to come back to the internet again. All right, I see Nick's Flakes in chat is saying hi to MattClad, and I also say hi to MattClad because I'm afraid I am not MattClad. My name is Brian. I stream about Tiger Beetle sometimes. This channel on Twitch is called Iron Beetle with MattClad or something, and MattClad streamed earlier today, and it was super exciting, super informative. He's got a really great haircut that is I'm jealous of, but my haircut is also pretty good. Well, I'm covering it up today. But we're going to be doing like some haircut competitions probably on this stream for a while. See who's got the best hair. He is a lot younger than me, and he's got some great hair. Oh. But today we are streaming about creation of the Rust Tiger Beetle client. This is my current project, and I'm streaming the entire project on Twitch, creating a Rust client for Tiger Beetle. Okay, back to what I was doing. We're going over and we're going to try to figure out how to annotate this particular error type. We're creating an error to wrap the Tiger Beetle status, which is the underlying error type returned by the Tiger Beetle client library that we're binding to. And before, we were looking at our status error that we, so this error that the compiler gave us was saying that this error type we're implementing doesn't implement display, which is what you have to implement in Rust to print a string from a type, which is required of the Rust error type. And to implement this error type, we're using the common this error crate, not just open coding the error type. Hardly anybody open codes the error types in Rust because it requires a lot of boilerplate. And I am just trying to get this macro, derived macro from this error to implement some kind of display implementation. So I'm going to say TB client status error something. It doesn't matter right now. We're just trying to get through this because we're yak shaving. We don't want to be implementing error types right now. We want to be doing other things. So we'll see if this works. It says, nope, not expected here. And this is great, though. This is a great error message because this error message doesn't come directly from the compiler. It can't possibly come directly from the compiler because it's about a custom attribute. So this comes from the this error crate, but it's very readable, just like an error from the compiler. And it tells us exactly what to do, which is super great. Rust error messages are the best. Okay, and now that we have an error type here to wrap our TB status from the underlying FFI, we can go down here and change all of these types. So this is the result type. We have a trait here that defines the client, and then we have an implementation down here. And instead of returning a TB status, we're going to return a status error. All right, so up here, instead of returning just an error of status, it's got to be an error of status, error of status. And this should satisfy most of these errors. It's up there here in main, you can see we expected main to return a result type, and it actually returns a unit type. Oh, these errors are so pretty. So in our main function, go find it over here. And chat, please remind me if I forget to switch scenes and you're not looking at code or not looking at what I'm looking at. I'm very bad at that. So our main function here returns a result now, and down here you can see it just kind of trails off without returning anything. So we have to return something down here. Now this should all check again. Okay, now we can finally get on to the thing we originally set out to do like 30 minutes ago, which is make this init function do something sensible. All right, so TB client here is a null pointer, and let's go ahead and refresh ourselves about the TB client API. So TB client takes a out pointer to a TB client pointer, or out pointer to a pointer, and it's going to fill in this TB client with something opaque. We're not allowed to see it, but that's all the internal state of the client. I'm just preoccupied with the notion that the stream title is about Iron Beetle with Matt Clad, but I'm not going to try to understand how to change that on Twitch right now. All right, so this TB client, we're filling it in here, and then we're stashing it there. So that we're doing correctly. This 0, this is the cluster ID. This cluster ID now we're passing in correctly. So this should be cluster ID, but I noticed that cluster ID is a U128, and as I recall, I thought I defined it as a U size here, but it's type inferred. So cluster ID I can pass there. Then this null pointer is a pointer to a C string, I assume. Okay. This is an address pointer and an address length. So it's not a C string. That's very convenient for us. I was afraid I was going to need to convert this to a C string, but the underlying API accepts a string length, which saves us a step of going and looking up some Rust FFI documentation. So this is just going to be a pointer to our address. So it's our address dot pointer, I think, and it's a const pointer. And address dot pointer, I think, will give us a const pointer, whereas mute pointer will give us a mute pointer. And this is going to be address dot len, I believe. And this completion, again, that's the U size that I was thinking of. Interesting that this is defined in terms of the host machine pointer size. It's kind of uncommon in Tiger Beetle to define values in terms of the machine pointer size, the word size, as a U size. I might expect this to be like a U64. But this has no impact on the underlying protocol. So this is just a local thing. It's just a number for use locally. And that is our on completion context. And then again, our on completion here, we're passing none into this ugly type here, which is an optional function pointer. And I'm going to keep passing none here and just compile and run it and see what happens. But I'm guessing this is not going to work still, because almost certainly the client is expecting a useful callback here. So hopefully, I'm expecting it to panic because this is a null callback. I just want to test if my assumptions about how this are coded is correct. Now we don't really need to print the status anymore because we're returning it here. So we should see it if we get a bad status from TB client in it. All right, let's see if this builds, and then we'll run it and see what happens. And it does not build. Look at this. Oh, this is so great. No method name pointer on our address, so I tried to guess that function name, and I was wrong, and it's as pointer. In general, in Rust, in the standard library at least, there's a bunch of patterns for how methods are named, and as something is a common way for casting a value to another value. I should have known that, but I forgot it. But compiler just told me, like, maybe this is not what you want. This is probably what you want. That's so cool. As pointer. And Rust, very commonly, you can just have the pointer, like the compiler just tell you the next thing to do. You can write bad code and the compiler will tell you what to do instead. All right, this argument is incorrect because the API is expecting a U32. So that's interesting. So before we were talking about how the TB client API for local values, it's using usize right here for this completion context. But this address length, it's the length of a string. It's also kind of like host dependent, whether it's a 32-bit or a 64-bit architecture. You could have a length that is 64 bytes long, not 64 bytes, but length that is representable within a 64-bit word. Something like that. So I might expect this to also be a usize, but instead it's a U32. So we have to kind of cast this to a U32, and I'm just going to do this. In Rust in general, doing these plain as casts is kind of a code smell, because what if len doesn't fit into a U32? In a lot of like really hardened code, you want to use casts from the standard library that will panic if like a cast doesn't fit. That's kind of one of the big warts, I think, in early Rust, was having these as casts be like the default syntax that are lossy. This is a lossy cast. And almost certainly, in most cases, you don't want to do this. But in here, I'm just going to be sloppy and do this because there's no way we're going to have strings that are that big. But the thing is, you have to, like, every time you write one of these lossy casts, you have to like look at it and reason, like, is this possible for this to not fit into a U32? Whereas if you used a panicking cast, you wouldn't think about it. You would just say at runtime, this is going to fail if the cast doesn't fit. Yeah, so Nick's asked in chat if we should put an assertion here, and you could, but that's kind of the point of these casts in the standard library. Let's just go look at one actually, now that we've talked about it so much. We'll go do it the right way. All right, let's go to the Rust stud, and I don't already have this in my history. And, oh, it's been a while. What are these functions called? Maybe like toU32 or asU32 or as. Here's a toU8. Oh, it's probably a trait. How am I forgetting this? You know, on stream, sometimes you just completely blank. Let's just go look at the usize type and we'll find it. Oh, checked. These are right. There's a million checked things. Checked. Nope, this doesn't look like it. I'm going to open my chat window in case somebody wants to give me the hint about what these functions are called again. From and to. I can probably just call, I think there's a trait called like to or from. To. Nope. All right, we'll go to ChatGPT. Go away. All right, in Rust, how do I safely cast between a cast from a usize to a U32 and panic if the cast will be lossy? Try from, of course. You can tell it's been a while. All right. Well, I was going to look at the docs, but this is actually better than the docs because try into and try from are very generic traits. So if you just go look at them, they're going to talk, their docs are going to be in very generic terms, but you can use these to cast from lots of different types. So I'm going to say, and because I want to say dot into, so I can just say into, and this will panic if this doesn't work. And this is actually pretty nice. And I can just say into without specifying a type here because of, thank you, chat. Didn't switch my OBS scene. I knew that would happen eventually. I appreciate it. So this into, I don't have to specify a type here because type inference, because TB client init takes a U32. So Rust will just figure this out. Oftentimes, you might have to say like into U32 and put a explicit type on your cast, but I don't need to do that. I'm going to say into, and then I'm going to say expect. I'm going to do this idiom that only I use and nobody else uses. I'm saying this is impossible. Actually, I'm not going to say this is impossible. I'm going to do it the right way. I'm going to say, actually, I'm backtracking a lot here because there's so many ways to cast things in Rust and handle errors in Rust that I'm doubting myself about how to do this. This into is infallible or fallible. So this should panic if this cast doesn't work. Let's see if this builds. Expected U32 found usize is our old error message. The trait, okay. This is infallible, so this isn't defined for the cast from usize to U32 because this could fail. So we have to say try into, and let's go try to build that and see what it says about that. It's going to give us another error. Try into, this could fail. And so it's telling us we can put a question mark here to handle the failure case. And that means try into is returning a result, which Should work pretty well. Oh, okay. So much of this stream is going to be about explaining Rust errors. So this error, this try into returns a try from int error, and our function returns a status error. And our status error doesn't return a try from int error. So again, this case is literally impossible. So I'm going to say expect. And this is kind of what I write for unwraps that I think should never happen. You could also say expect U32. That's probably more idiomatic. Like this is literally never going to happen. But if it happens, somebody can come find it. And if somebody's reading this code, when they see expect here, they'll know like, okay, whoever wrote this actually thought about this error case and they think it's not possible. Whereas if I wrote unwrap, unwrap is just kind of like often used for temporary purposes or test purposes. So if someone came along later and saw this unwrap, they'd be like, well, is this actually possible or is this impossible? So now we've done a pretty big yak shave there and done our cast from usize to U32 in a much more idiomatic way. And let's see what error messages we have now. So yeah, in chat, Nix is saying I didn't know into panicked, and I don't think it does, as we just saw, like it just doesn't define that conversion if it's fallible. So you can't call into there. You got to handle the error by using try into. It sounds like Nix knows some Rust, so hopefully they will back me up when I forget stuff. All right, we got still some errors here. Address.lin, I put an expect. Oh, I need to put try into, then expect. Now this pointer is incorrect because we're getting a pointer to a U8, but this API wants a pointer to an I8, which is kind of probably just the difference between a how the API defines a C char versus how Rust defines a U8. So in Rust, this string is an array of U8. And in C, the actual type of a char is kind of platform dependent, but according to this error, it's probably an I8 in almost every platform. But it can be an I8 or a U8, depending on what platform you're on. But to get rid of this error, I can just tell it, you know, I can just do this actually. That'll probably work. Yeah, so you can just say cast this to whatever you need, which is very lovely, but kind of bad Rust. So I'm going to say star const. We'll see what they said over here. So in the API, they said they wanted a OS raw C char. So you can see here in the standard library does provide a few common C API definitions for convenience. It used to be you had to go to another crate to get this definition of C char. But here we can just get it from the standard library, especially C void is very hard. You would need C void to be defined the same way everywhere. And so the standard library defines a few very basic C types. But we'll just go import this from the standard library just the way this bindings does. And then down here, we'll use the actually correct type and say star const C char. All right, now all that builds. Now we're calling TB client init finally with mostly correct arguments. Nix, you haven't written much Rust after OCaml. That's fine by me. I'm not offended at all. Rust was originally written in OCaml, and I never really learned much OCaml. But apparently a lot of people that Rust has a lot of ML influence, so should be relatively easy to learn one when you know the other. But at this point, my life is mostly Rust and lately Zig. All right, I'm losing my train of thought as I'm chatting. Okay, so what we're going to do is call this and just see what happens as we're passing this null callback. And then the next thing we're going to have to do is just figure out what to do with that callback. Cargo run, and it did not complain about a null callback. Okay, that's interesting. So I expected that like you can't do anything useful with the Tiger Beetle client if you don't give it a callback, because probably a lot of what you do with the client is going to be done in this callback. But it appears that we did successfully initialize the client. Okay, in that case, this init echo, I don't know what this does, but it is very similar in how it's defined. And I'm wondering if we should figure out what that does, because maybe that'll give us like useful echoing debug information or something. I wonder if that's documented anywhere what this init echo function does. Let's go ahead and do a little bit of digging and see what init echo does, just to kind of decide whether we want to actually implement this or not. And if we remember all the reference things that we had open, TB client exports is all the exports. Init echo is addresses. It's interesting, this client seems to take one address. Oh, interesting. This address pointer says it's null terminated. The syntax in Zig says this is a null terminated slice, but I did not pass it. I did not pass it a null terminated slice. And this is an addresses pointer, and I said addresses len. I may be calling this completely incorrectly. This addresses len might be saying this is the number of addresses inside this addresses pointer, because the addresses here internally, the client should take a bunch of addresses. And no, it's just one string, and it doesn't care about the null termination of this string. It is just slicing it to addresses len. That is curious. So this API is claiming I want a null terminated string and the length of the string as some kind of slice pointer cast of addresses pointer from 0 to addresses len. It seems to just be ignoring the null termination. I wonder if it's just kind of like a cover your butt thing, like in case we accidentally treat it as a C string. I don't know. Maybe somebody will correct me at some point. I'm still not sure. This says it's addresses, but it's also just a string. It's not an array of strings. So I have no idea how this address is parsed. All right, so TB client init. This is right, or if we recall correctly, if we recall what we're doing, I'm trying to figure out what the difference between init and init echo is to decide whether to implement init echo. And init calls init, and client calls init echo. So we're gonna have to dig deeper to figure out what init echo does. And to find init echo, I'm gonna go ahead and look in tbclient.zig and see if it's over here. Yep, right here. This is init echo. Init and init echo. Okay, so these are not calling two different functions. This is calling init, and this is calling init. Allocator cluster ID. What is the difference between these two functions? Init echo, init. There must be a difference between these two functions. They both call default context init. Oh, testing context init. Gotcha. Okay. So again, if you didn't catch that, the init function on the client calls default context init, and the echo client calls testing context init. I don't want to look any further because that sounds useful. I think I want to test with the testing context. So that means I'm going to go over here and I'm going to implement init echo as well, and we're going to use that while we're figuring out what we're doing. RS. Just find finding my references again. And this should be the exact same thing. I'm just going to copy paste. I don't really mind copying pasting here because it's a pretty small amount of code. But instead of init, we're going to call init echo. And let's say, go to our main function again. In the future, we could extract all this duplicated stuff and just pass like a closure that calls the correct TB client init function, but it's a pretty minor thing. And instead of calling init, we're going to call it init echo. And we'll just see if like that prints something different. No, it doesn't seem to. All right, now we've got to take a step back here and think a bit. Let's commit what we've done. Take a drink of water and collect our thoughts. Maybe go check on the stream. Kind of clean out our brain again, because it's I've been kind of talking nonstop for almost an hour now. In fact, I'll switch scenes and just chill for a second. And if you're wondering what I'm doing as my eyes dart back and forth, I'm just like switching between windows, trying to remember exactly what I'm doing right now. Okay, so let's think. So we've implemented the init function, and now we're going to do something useful. We know there's a callback we haven't provided, and there's a few other functions, but there is not much else on this API. So as far as I know on this API, and I'll switch back over here to our code window. If you look at the API, there's a function to get the completion context, which is probably just going to return the thing we already passed in, which kind of almost useless, but maybe useful if you're using a bunch of clients, which is a common pattern in Tiger Beetle, and then a dinit function. So these two, so unimportant, they don't really matter to what we're doing now as we're figuring out how all this works. But submit, we're going to submit some kind of request defined by some packet that we haven't looked at. And then at some point in the future, almost certainly what's going to happen is we're going to get a callback somehow, somewhere. And as I've been like thinking about what we're doing on this stream, like I'm wondering where this callback is called, because I assume submit is not blocking and the client doesn't provide any blocking methods to say just like wait in an event loop until we get something to do, which makes me think like, and I don't think we bring our own event loop to this client. I think IOUing is built into the Tiger Beetle client, which makes me think like maybe this is called back on another thread. There's nothing here that lets us wait on an event. So probably we need to submit a client next, and then we can figure out what to do about this completion callback. Although I kind of want to know what the arguments on this completion callback are so that I have some kind of idea of what we're going to be looking at in the future as we handle events. So let's go over to the tbclient.h and maybe the, I'm always forgetting the name of these files. tbclient exports maybe. Exports submit and init tb completion type. Nah, not exports. tb client.zig. What did I just do? Oh my gosh, Chad, I've never seen this before. See this, what is going on up here in this window here? I've done something very confusing. All right, if anybody knows Emacs, tell me what I broke. I broke this so bad that I might just restart Emacs. I've never seen this thing up here in this top line before. Yeah, just kind of resetting where I was because I'm so confused. That's embarrassing. This is going to go up on YouTube eventually for posterity and everybody will see me screwing up in Emacs, which It's probably to be expected. It's Emacs. Let's go back, find our tbclient.zig and our init. All right, this is our completion callback, and our completion type is this big old thing. This is our completion callback, and it takes a context, which is again just that number we passed in, our tbclient.t, which is an opaque pointer, a packet pointer, which is probably the same as the packet we're passing into the submit queue, some kind of timestamp, and yeah, a buffer that represents the result, which we're probably going to cast to something. Okay, that's all pretty straightforward. I think the next thing we'll do then is say, let's define a completion type. And we'll define this as a Rust closure. And actually for now, we're going to define it as a Rust function, because as a closure, it's going to be more complicated to like turn a C function pointer back into a Rust closure, because you need some additional state passed around, which is definitely what this context is going to be used for in the future. This context can say like, let's take this callback and whatever this Rust specific context is and combine them to create a Rust closure. But I don't know what we need to do with that yet, so I'm not going to bother to do it. Yeah, it might even be that in the final Rust API, that this context doesn't even expose to Rust. This context will just be the thing we use to reconstruct the Rust closure for the callback. And to reiterate what I was thinking earlier is that this API we're defining right now is probably not the final Rust API. There's probably a more high-level Rust API on top of this that does things like manage these contexts and convert them back to closures. But for this API, I'm thinking about whether we want to redefine this completion type in terms of Rust or just pass in a TB completion type directly here. And I think what we want to do is define our own completion type. We're going to make a lot of mistakes right now and come back and fix them as we learn things. So we're going to make our own completion type. And the reason why I think we want to make our own completion type is because we already have our own client type here. And one of the things that the completion contains is the underlying raw client. And we don't really want to pass that back to Rust. So I'm going to define a completion here. And then when we get this completion, called, we'll kind of convert these types internally and then pass them back to Rust. And in fact, I don't want to do this yet because understanding how this completion handles packet, I will understand this better if I go implement the submit function first and understand what this packet is, because I don't know what that is. So let's go find the submit function and tbpacket.t. And this is defined right here as this Zig packet. And I'm kind of right now thinking a lot of things at the same time. And so if the last few minutes it seemed like, what is this guy doing? It's because I'm thinking about several possibilities at the same time, and I'm not sure exactly what I want to do next. And a lot of it relates to like whether this Rust code I'm writing right now is like trying to wrap the underlying C abstractions and Rust abstractions, or if we're just trying to kind of like use those same underlying C abstractions. And I'm kind of torn about that. But again, if we go back and think about what we're doing here, we have a trait, and this trait is expected to be implemented in two ways, one in Rust and one in terms of the C API. So that is making me think that like we shouldn't be using the underlying TB client types within this Rust code we're writing. We need to be wrapping them all up in another layer of abstraction. So I'm kind of trying to decide what to do next as I am also talking about what we're looking at on screen. Struggling a little bit. But I think what we want to do is go ahead and try to define this packet and the submit function. So if we look at our TB packet, this is inside of packet.zig. And instead of looking in packet.zig, I think I'm just going to go again back to our generated TB client C header file and look at TB packet, this type. So this is just showing us what our packet is. All right, and our packet, the first thing obvious here is our packet is a linked list of packets apparently, which is kind of scaring me because intrusive data types in Rust are kind of a pain in the butt. So if the packet contains a pointer to the next packet, I'm not looking forward to figuring out how to represent that in Rust. So this packet internally could contain another TB packet. You know, some user-defined data, operation status data size, user data, and then we have data. And these are just pointers to something. Batch next, batch tail. Here's some other kind of linked list. These are both packets again. So we have a pointer to the next packet, then we have a pointer to the next batch. Probably we're submitting patches in batches. All right, we're looking at a bunch of stuff that is starting to concern me because there's a lot going on here. Batch size, batch allowed, reserved. Now I'm thinking about this Rust packet and whether to try to like represent all this stuff in a way that could be implemented in two different ways, or whether I just want to like stuff a TB packet in here for now, just to get something working, because there's a lot to take in here and a lot to understand. And part of what I'm doing on the stream is just to understand what the heck is going on in the client. So I don't really need to think too much about the Rust abstractions now because I don't really understand the Rust abstractions yet. Hey, Steel Tormentor, welcome to the stream. You joined at a very confusing time because I'm just kind of struggling through understanding some of the details of the client. I'm finally getting to the hard part, and getting to the hard part on stream is making me sweat a little. But what I think I want to do for now is just this packet, I'm going to say contains an internal TB packet. And I just want to call this API and see what it does, because we're just kind of exploring. So this Rust packet just contains a TB packet T. Let's get something going. And then in our client, we'll just figure out how to construct a TB packet T and see what happens when we call the underlying TB client C code. Yeah, this is a TB client, TB packet T. And I'm just gonna make this pub. It's just a plain old data type here for now. I'm just gonna expose this directly to the test program we've written. And then this TB client, I'm gonna make this pub mod so just I can reach right into it from our main function. And then submit down here, it should be pretty obvious how to implement submit. And I'm gonna go implement submit in the obvious way. All right, TB client submit takes a client and a packet pointer. So here, if we have a packet pointer, we can say TB client submit self.client, I think. Yeah, so our client contains a TB client. And the pointer to a packet. So this wants a pointer to a packet. And that makes me think this needs to be on the heap and have kind of an arbitrary heap lifetime. So I actually want to go up here to this and make this not a packet, but this is a mutable pointer, but a mute pointer to a packet. And here we can say packet dot, what do they call this field? TB packet. All right, so that's your type check. What is completion? Oh, I haven't committed to implementing that yet. Call to unsafe function, easy to resolve. We say unsafe. Let's make sure that checks, and then we'll go to our main function and we'll start constructing one of these packets and figuring out what the client does in response to a packet. So now we have a client and we need a use TB packet. And we're probably going to need use that internal stuff that we exposed, TB client as TBC. Let's give it a shorthand. And in an ultimate API, we would not want to expose this underlying TB client stuff because it's not Rusty, it's CE. But for now, while we're figuring out how this works, we're just going to use it directly. And we're going to say client.submit packet. And this doesn't return any errors, so submit can't fail. Interesting enough, what happens if we submit a null pointer or something like that? Probably just a assertion. I'm going to say let packet equals, I have no idea. And again, we'll just see if this type checks. Yep, and it's not happy about all this unused stuff, but that seems okay. All right, this is all unused stuff in our main function. Unused variable client, that doesn't seem correct. I used it right there. Oh, probably because so this error message, these are all warnings for unused stuff. It's saying that this TB client is unused, but that's in our code. You can see, yeah, we use the client right here. But as far as the control flow in the compiler sees like, oh no, we definitely panicked here. We never even got to the point where we use the client, so the TB client is unused. So this stuff, these warnings are all fine for now. They're going to go away as we write this code. And so this packet, we got to make a packet. And now we're going to have to really dig deep here and figure out what all this stuff inside the packet is. And we know we need to allocate this bad boy on the stack. And there's some kind of link listy thing going on here between packets. And this is the point where it's like, should I go like look up the Tiger Beetle FFI docs if there are any, or do we need to go like look inside the Go implementation maybe to see what they're doing? But for now, that's going to be pretty boring on stream, so I'm just going to like fill these in with stuff and see what happens. So let's start filling in this stuff. Okay, this packet is going to be TB packet. And we're going to have to allocate this packet. TB packet equals, this TB packet type is a TB packet T inside of TB client. And how do we just allocate a thing in Rust? It's probably with box. Box new, is that the way to do it? TBC, TB packet T. Let's look at the Rust def of this. Right now we're referencing the C definition, but it'll be easier for me to understand how to define this packet if we look at the Rust definition instead. So that's in Rust source TB client.rs, TB packet, TB pack it. There it is. Here's our packet. TB packet T. In fact, I'm going to define this all in line here. No, I'm not, because I need to take an unsafe pointer to this box. So in Rust, if you just want to allocate a single thing, which is pretty uncommon, you just create a box to it. A box is like a storage location on the heap. And then we can take an unsafe pointer to this box when we stuff it into this TB packet. It's going to be TB packet dot as pointer probably. All right, this TB packet T contains, let's just list out all the fields. User data, and then we'll, compile it and run it against the client and see how the client complains and slowly fill in these fields as we understand them. Status. Let's copy all this stuff. And the syntax, I don't remember if this is a colon here or there's an equals. The compiler will tell us in a second. All this stuff is just going to be to-dos, and then we'll ask the compiler to help us. And this is reserved. This is probably just going to be 0 bytes. There's definitely some C function that'll give it to us. We can see if it'll do it with default. Maybe not. We'll see. All right, lots of unreachable expressions because of those to-dos. We missed a field, status. Okay, status is after operation. Okay, as pointer is not how you get the pointer in a box. And maybe I just take a reference to it. That can't be it. But it might tell us though. It says expected a raw pointer. We have a box and we can dereference it. Okay. Really? This is okay. So the compiler is suggesting, I'm just kind of like throwing syntax at the compiler and getting the compiler to tell me how to fix what I'm doing. And so this here, this TB packet, is supposed to be a pointer to a packet. And in Rust, what I have is a box of a packet. And there's some Rust syntax to get the raw pointer out of the box. And what I tried to do is just say mute packet, which is a mutable Rust reference. And the compiler didn't like that, but it's saying, maybe you want to dereference the box and then put an mute in front of it. So it's saying add this dereference to T packet here. I'm kind of thinking that's wrong, but maybe dereferencing the TB packet is like, I'm looking at it and I'm thinking, no, maybe I want to do that, but let's try to do what it says. And it compiled. So I dereferenced the box. Okay, this makes so sense. All right, so what I did here, if we look, the compiler told me exactly what I did and I just didn't understand it. So what I created was a Rust reference to a box. What I really wanted was a unsafe mutable pointer to a TB packet. So what I did was this. What I really wanted to do is dereference this box. And a dereference is going to get me a Rust reference. A dereference is going to get me, no, it's kind of going to get me the thing inside the box. It's not going to give me a reference, but it's going to give me like a path to the TB packet inside the box. And to turn that into a Rust reference, we say mute. And then this automatically coerces to an unsafe pointer. So I didn't explain that well, but fortunately the compiler just told us like all this sequence of dereferences and coercions. This is a dereference of the box, creation of a mutable Rust reference, and then all of this gets coerced into an unsafe pointer, which is, cool. And something about this feels very unsafe, and I have called a safe function. Something here feels unsafe, but I haven't called any. Interesting. It feels unsafe that I just took that unsafe reference and passed it to a safe function. TB packet is. I'm just looking real quick at how I define packet. It's an unsafe pointer. Yep. In a REST API, this wouldn't stand this way because I just created an unsafe pointer and passed it to a safe function. Anyway, we can run this, and presumably it's not going to work correctly. All right, all these are to-dos. So we got to get rid of all of these to-dos now. For these pointers, I'm going to say this is some kind of linked list to a next packet. And it's probably valid to say I don't actually have a next packet. I'm going to just say this is null. And that's in stood. And there's some other kind of linked list action going on here for batches, batch next and batch tail. I'm expecting batch next can probably also be null if there's no next thing in the batch or no next batch, whatever that represents. This batch tail, though, I'm not so sure, but we'll assume it can be null for now. No idea what batch size and batch allowed might be. No idea what user data, I can probably just say I have no user data. This is presumably client specific, application specific, but I don't know. I mean, this is a packet, so it's going to be passed to the server. Data, I would expect to be some kind of flattened version of a request to the server. But user data, don't know. This might be just client side, like something to let me correlate, kind of like context was in the client, like correlate the packet to something else on the app. Operation, I need to go find some operation. Status, I'm guessing this is filled in by the client later, but I don't know. I'm gonna say status 0. Data size and data. I'm really gonna have to go figure those out. User data, I'm gonna assume we can do null again for that. But look at this, user data is a mutable pointer, suggesting that somebody might want to mutate user data at some point. Same for data. Somebody might want to mutate that value. I feel like a packet, like I'm just like sending it off, serializing it, and that's it. But this type is suggesting that like the client might want to mutate this data, or maybe when I get the callback, I want to mutate this data. These make me wonder if these are like just defined in a sloppy way or something, because I'm just thinking about what this function does, I want these to be const, but maybe they actually do get mutated. All right, so now we got to go figure out how to, like what operation we want to try to submit in our packet. And I'm going to take a drink and just kind of recap what we're doing here. Ooh. So again, what we're doing is sort of just doing some prototyping, figuring out how the underlying Tiger Beetle client works, because I don't know. I've never written a Tiger Beetle client, never even used a Tiger Beetle client. I've used the REPL, but never coded to the client. So right now we're just kind of understanding how to work with the TB client FFI. And that's going to kind of inform our understanding of how to write abstractions around it in the future. So all this code we're writing is kind of junk prototype code right now. And the next thing we probably want to do here is go look at the set of available operations, figure out some simple operation to submit to the client for testing, and then go define that here in our main function, send it off to Tiger Beetle and see how it responds. Although as a first step, I could define this as operation 0 and send it a null pointer for data. And we'll just see what how the client responds. Say no data, and we got more null pointers. Oh, also this batch size is tough because I have no idea how to deal with batches at all in the client. Batches allowed is a U8. We're going to run this and see what happens. Oh, so I said pointer null for all these, but these are actually mutable pointers. So I think this will probably be null mute. I always forget whether the mute is like a prefix or a suffix, but I'm going to say null mute. So now we've got just a packet filled with zeros. Cannot borrow as mutable. Okay, that makes sense. It's just Rust stuff. This needs to be let mute. And client cannot borrow as mutable because we defined our trait here. Submit, we said the client is mutable. And since this is a Rust abstraction over a CFFI, we're kind of just like using our judgment to figure out whether this is a mutable self or an immutable self. We could make it work either way, but presumably submitting something is going to mutate something within the client. So putting this mute here kind of signals to the caller like, you know, this is definitely mutating something somewhere internally. But you could also, like in Rust, model this as internal mutability. Say like, well, this API looks like it's immutable, but internally it's mutating something. That's something that you do in some Rust APIs, especially if they do I/O. You might not bother to expose like mutable self pointers for things that are just mutating something by sending data off. Again, I lost my train of thought, but this client needs to be mutable. Okay, so now we called submit, and it didn't complain. I'm a little concerned about that. Like, am I actually doing anything here? Because I just submitted some garbage, and it seems to have run. I wish I could like get Tiger Beetle to print some logging information. I really don't trust this because it looks like it's submitted. But that can't be a valid packet, just all these nulls. And also, I don't even have like a server set up. So this client is initialized, but is it actually doing anything? Like it says it's initialized, it says it's submitted, but there's no server to connect to. So what is actually happening within this client? I'm kind of concerned, guys. So what I think I want to do is commit what we got and get a checkpoint, and then go figure out what is actually happening within this client. To do that, let's going to look at the tbclient.zig and look at init echo, and like maybe this initialization doesn't connect to the server, like, but it does report errors, so it's not doing nothing. Maybe testing context allows it to, I don't know. I'm feeling like something is going wrong here silently that is kind of concerning. But let's go look at testing context in it and figure out what's going on in testing context in it. At this point, we're just going to kind of trace through the Zig code and to understand what should be happening, and maybe insert some debug print lines and just try to get an idea of what is going on within the code. So here's our testing context, and there's our default context. Echo client type, client type. So we have two different clients here. I'm also wondering if, because I'm initializing in the Echo client, and as we saw, there's two different clients. And maybe the Echo client is the wrong kind of client. Maybe it's doing something very strange. TB client, import TB client. Where is TB client? And people who watch MatClad stream are probably very frustrated with how I navigate code. I am just like literally searching for strings, whereas he is much more fluent in how modern IDEs work. TB client, TB client, TB client. Echo client. I'm just now figuring out where Echo client is. Client C, TB client, client C. Oh, there's a directory here I didn't realize. There's an Echo client here in the TB client directory. TB client, Echo client. Exposing the same, this is not a real client. Custom demuxer, which treats echoes, results and echoes them back. Echo client, Echo client. I'm feeling like Echo client may be not at all what I want here, and maybe we should use the real client. I was thinking Echo client maybe just added some logging or something, but it seems like it's doing something pretty special. Okay, so now I'm not using the echo client. So I'm going to make sure that our function init is calling client init and not the echo client. And let's just forget about this echo client for now. I need to basically go ask somebody, what is an echo client? So our client type is this client type coming from the VSR. Client. And so when we init context type, break context type, client, context type. What is a context type? So our default context is a context type of a client. So we actually need to kind of look at the context type, not the client type. All right, real quick, I want to go look at what this init function does. It creates a context and then it calls context to client. Context to client. Oh, there's a pointer cast. So a context and a client are the same thing. Okay, well, that's interesting. VSR context client. Where was this context again? Client type, context. Oh, context. Okay, so context is defined within the TB client bindings, but the client is within the VSR. So this context is just kind of like part of the TB client API. It's not a core part of the VSR. TB client context. So a context type returns some kind of struct. And we're casting the context to a client. So this struct I would expect to be the same as a client, which seems very suspect. Probably something I don't understand there. Go back to TB client and look at function init. Call it default context init. This is default context init. And there's all kinds of stuff it's doing, creating an allocator, parsing addresses, might return errors if the addresses isn't correct. There's some debug logging. I would kind of like to turn on this debug logging. Anybody knows how to do that, I would love to know. But that seems like it would take me a long time to go figure that out on stream. But we could say log debug. We can convert this to info logging. Log debug. I bet there's something I put in like, I don't know how to do it. I don't know how to do it. I'll ask somebody sometime. But I can say replace string log.debug with log.info and recompile our C client. We got to be in a different directory to do that. Zig build clients C. Anytime we change the Zig code, we're going to have to go build the library again. And here we can say run. And it didn't log anything. That is concerning. Like maybe to get it to log something, I have to do some kind of special setup for the library case. We're getting to the point where I just want to make sure this function is actually getting called at all. We got to build a library again. Oh, this is it, chat. This is the stuff. So I put a panic at the beginning of this function, right? And now all this stuff is unreachable in this Zig function. And there's no way to disable all this stuff. Like Zig is just completely unhappy that this control flow can't reach all these statements. So what do? Like, I want to panic here, but I don't care about any of this stuff. So what I'm going to do is I'm just going to go like comment it all out. And it didn't panic. So chat, this function is not actually getting called. Now I'm really kind of creeped out. I don't understand what's going on. So our main function is calling init. Our init function is calling tb client init. And we'll put a panic here in Rust and just make sure that this function is getting called. Okay, yeah, that's panicking. And then tb client init is in tb client.zig init. This is calling, is this really not being called at all? Panic. And then of course this stuff will be unused. I'm very confused what's going on here now. Client init. Client. I'm gonna go look at that exports file that defines what the client exports are. Not that, it's in source, exports, tb client exports, init, it's right here. Maybe this is returning an error that I'm not handling correctly. Like maybe this isn't actually happening. Return success. Like tb client, it just seems like this is not getting called at all. What is tb.init? What is tb here? Oh, it's just a namespace. tb client. VSR tb client. tb client sig. I'm wondering if, so this tb client, this init function is calling tb.init, but I'm wondering if this tb is not the same as this tb client module over here and is instead in the VSR module. Like maybe function init. This is the init function that's being called? No, that can't be right because this option struct is not being called. All right, so init calls tb.init, which has exactly this function signature, default context.init, but this is never executing. Did I not recompile this? Yes, maybe that's the thing. I didn't actually recompile the library. What is this not liking? Client.zig 162. Yeah, okay. So right here in my, yeah, okay. So I stubbed out this function to panic. But now all these arguments are not being used too. So I have to say, this is not being used. None of this is being used. Okay, same thing in my other one that I tried to stub out. All these arguments I have to tell the compiler, not using them. Rebuild the C library. All right, that's built. And now we should see something panic. Great, now I figured it out. So to client SIG, it's panicking WTF. So we can uncomment these comments. And now we should see this panic here if we rebuild the library And this having to rebuild the C library and then run the Rust program is kind of tough right now because I'm forgetting to rebuild the C library as I make Zig changes, which suggests maybe we need to add some rules to the Zig build script. Okay, so that panicked. All right, so earlier where I thought these wasn't being called, I was wrong. This is all getting called. I wish I could not build all these other architectures. That's got to be taking a little bit of time. But this init function is succeeding. So I could probably put like a panic right here just to see if this is succeeding. Like maybe there's an error being returned here that I'm not handling correctly. If we look at our library, we have a status here. And if it's an okay status, we return a Zig client. Like this looks correct. We could print the status here. Just to see what that status is. It's 0, so that's a correct status. So just init succeeded. Let's put a panic here just to see. And then this context is not being used, so to say you have to recompile the C library. And it doesn't like, what doesn't it like? Oh, this is unreachable because I put it in the wrong spot. Oh, this is going to be so boring to watch, chat. I'm sorry about all this. Pointless discard of local variable. Okay. It doesn't like that discard. So maybe this will just work. Rebuild the C library. Always remember to rebuild the C library. Okay, that panicked. So this init function is working. There's a submit function. Let's just read the submit function. What does it do? All right, so you can see there's some atomics here. So there's definitely multi-threading going on. Before we were wondering where callbacks happen. So there's threads involved here. Get message, release message, dot request, packet, message dot header. Where does it use our packet? Because the thing I'm thinking is like this packet is so bogus that we gave it. Operation, yeah. Packet dot batch size. This is message header. This is the actual network message that it's sending, presumably. Packet, copy all batched packet event data into the message. Batched packet event data. It equals packet, so it's going to use our packet. And it's going to iterate over something here. What does this idiom mean here? It is a maybe pointer to a packet. It's iterating over it, batched. Copy all batched packet event data. Batch.batch next. I feel like this is just like accessing a weird Zig idiom to access this maybe packet. Packet, I don't understand this at all. Packet, this is a non-null pointer to a packet. Down here, we put it into a maybe packet. Oh, we're probably iterating over this thing. We're okay, all right. We're going to mutate this optional and iterating over this linked list of packets that we were talking about before. So somewhere right here, we assign bash net. So this while is iterating over this linked list of packets. Oops, I didn't mean to delete that. While is iterating over this linked list of packets. This is an optional packet pointer. And as we iterate over each packet, we reset it to something else. Must be this is a Zig idiom. You'd never see something like this in Rust. This is weird. But you wouldn't use intrusive data types like this in Rust, where it's a linked list as a pointer to the next thing in the list. So we're iterating over the packet, and batch next is null. And then we look at our batched data size. All right, so probably we're looking at one of these cases is just calling us to do nothing. Event data, if the data size is greater than 0, if the data size is empty, it may be an empty array null pointer. Data size, copy disjoint. Here we break. So if we have a break to event data, it's a pointer of nothing. So we're copying our packet into our message body. So the data from our packet, we're copying into our message body. Like, I'm not really understanding all the details here, but the basics are we're copying the data into the message body. And when I called init, I gave a null pointer. So it seems like it's just happy about that. Like it's we're sending a message with no packets in it, I think. Like an empty batch of nothing, which I guess makes sense. But also, it's still, there's no server here. So maybe the client is like happy to not actually do anything until it makes a connection. And I'm not getting any feedback from the client about there not being a server and no connection. It's I'm a little confused still, but I understand that like we can send an empty packet. That seems okay. Batch next. So probably we can have batch sizes of 0 to start with until we understand batches. We're gonna be like, we're not doing any batching. So that's nice to know. No batches. Offset equals packet.batch size. Raw request. So the internal client sends some kind of raw request. And then presumably nothing happens because there's not actually a connection. So I'm wondering if my intuition there is correct, if the client is just happy to sit there with no connection and offering no feedback. Although maybe it's, we have a callback, right? And we haven't filled in that callback. So maybe if there's no client or no connection, like we're actually getting callbacks to handle those kind of errors, but I'm not seeing them because we haven't installed a callback. So I think the next step here is probably to test that hypothesis and set up the actual callback so that we have something for the client to, like a function pointer for the client to call on events. Right now, we're not handling events at all within the client. And we'll see if any of this, if submitting this empty batch is triggering any kind of callbacks that we're just not seeing now. And I kind of suspect we'll see some kind of callback saying like, oh, I don't have a connection, error, no connection. That would make a lot of sense to me. But chat, I do have to kind of take a break. My throat is a little tired and I've just been talking nonstop for about 2 hours. So I am going to take a 5-10 minute break and then I will come back and keep hacking on this client stuff. I appreciate you hanging in with me. I'll be back in a bit. I'm back. Okay. So I took a break and I got some snacks and I sat down for a minute. Hopefully, I have a little energy to keep accomplishing a little bit more today, but we've been going for 2 hours and that's about the longest I've streamed. I gotta tell you, chat, this is tough. We're doing stuff now where it's like I don't know exactly what the plan is anymore. We got to go learn what we're doing, go discover stuff as we go. Everything we've been doing is exploratory today, learning how the TB client works, what it expects, and how it behaves. And so I'm just kind of like trying to understand the TB client while talking about it. And many times during this work, I'm like thinking multiple things at once, and I have to say what I'm thinking. And it's pretty tough. And my workstation here is a standing desk. So I've been just standing for 2 hours and staring at code that I don't understand yet and talking about the code that I don't understand while I'm trying to think about next steps. And my brain is on fire. This is tough stuff. I mean, the code is easy stuff, really, but doing it all is pretty tough. Progress here is slow. And let's go ahead and try to just slow down, take some breaths, and figure out, maybe recap what we've done and talk a little bit about what we want to accomplish next. So today we've been just kind of writing exploratory code, understanding how the TB client API works. TB client is a library written in Rust or in Zig, exposing a C API that is bound by a number of other languages. Every language that wants to have a client talk to Tiger Beetle binds to the TB client API. And this API, as far as I know, is not documented. Like, we could be looking at the implementation of other clients to see how they use TB client. And at some point, I will definitely have to do that. But the approach we're taking today is to just poke at the TB client and see how it works. And go down alleys and figure out like, oh, that doesn't work how we were expecting, or this works in other ways, and just trying to understand what the TB client does and how it works just by coding against it. And so far we've got it to initialize, and we've sent packets to the client. We submitted packets to the client, and it all seems to work. But the client is kind of lazy in how it operates. It's callback based, right? It's asynchronous. So far we fed it data that looks pretty bad. Like, the packets we're sending it are just null packets. They're packets filled with 0. And the way the client seems to work is to take some number of packets, and each packet is like an operation to the server. And it'll batch them all up into a message, I think, and then send a big message full of packets to the server at once. And so when the client we say, here's a packet. And then that packet may have a linked list of other packets inside it that all get batched together. That's what it looks like the client does to me. But the actual process of sending that packet is kind of infallible. Like, submitting the packet is infallible. And so far we've just submitted the packet. And we haven't even like turned on the server and connected the client to a server. But as far as we've seen in the client is just like, oh, everything's going fine. But there's no server for it to actually communicate to, and the packets we're sending it are nothing. So we've learned a lot, but we've accomplished not a whole lot in terms of actually submitting packets requests to the server. And my hypothesis right now is that the client operates, it looks like it's multi-threaded because we can see some atomic operations within the client. And I suspect that the way the client works is that you have a handle to the client, and when you init the client, it probably creates another thread somewhere to do the work and to handle the underlying event loop. Because internally, TB client uses IOU ring. And the client's API doesn't really look asynchronous, but it does have a callback involved. And so I'm suspecting like you hold this handle to the client on your app thread, probably your main thread, and the client has it off working in a completely different thread, and it'll probably send you callbacks in another thread, which, makes a lot of sense. That's kind of easy. If that's the way it works, it's kind of an easy thing to integrate into any other language as long as they support threading. You just have to go like, do the work somewhere else, and then you send a message back, a callback, and then the client in whatever language is responsible for sending the message back to the app thread, probably. That's my hypothesis about how TB client works. And right now we've submitted packets to TB client, but we haven't installed the callback handler yet. And so the callback handler is probably where we get any feedback at all, because the init is just pretty much always succeeds, and submit looks like it just always succeeds. Whatever you submit as a packet, it's going to work. And right now we're sending empty packets. So what I think I want to do next is install a callback into the client and see what is being called. Because I'm hypothesizing that it's probably going to say like, oh, we don't have a connection to the server, and that'll probably be an error sent to the callback. And all the feedback we get from the client is going to be in the callback. So once we have a callback installed, we'll start getting some progress and feedback about what the client is doing wrong and what it expects. All right, so next step, we're going to go install a callback into the client. All right, and again, this code is all very nasty and ugly. I kind of started off this project by like creating an abstraction that I thought we would fill in, and we've already broken that abstraction just to try to splat data into the client and figure out what the client is doing with that data. So let's go back to our library and figure out how to define it to accept this callback. So if we go to our TB client header again and go back to our init function, TB client init, I think. TB client init. One of the things it expects is a function pointer for completions. And we can say, up here, we'll define that completion function pointer. And we'll say define it as a Rust. For now, we're not going to define it as a Rust closure. At some point, we'll have to support a closure. But for now, we're just going to pass a plain old raw function pointer. And we'll call this completion. And it's just going to be a type def for a function pointer. And it's going to be function. And we can look at our, we can actually just pass the, look at our generated Rust bindings. So we say function init, TB client init. It's expecting this. And we can just take this and copy it over to here and call that our completion type. And let's give these argument names so they're more helpful. Let's see if this builds first. Cargo check. Doesn't like that because it doesn't have the type imported. TB client. TB client. And I call this completion, but it's completion. All right, so TB client init expects this completion, and these arguments are not defined here, but if you look in the header, oh, these aren't given names here either. Where are these arguments given names? Let's look in TB client exports. Init TB completion T. So if the TB is probably VSR TB client, TB where is VSR TB client? VSR TB client. Oh, it is TB client.zig. TB client.zig. And completion T, there it is. So these are the field names for our completion type, or the argument names for our completion callback. Context client, timestamp, result pointer, and result len. And here our completion is a completion type. And again, This is all the abstraction that I thought we were going to start writing, but it ended up being that I don't understand the abstraction enough to do that yet. So I am kind of breaking this abstraction very bad just to do the testing. So we're compassing this completion type. We're compassing this completion type. And here we call tbClient init. And instead of none, we have a function pointer. And this should be sum on completion. Then down here, sum on completion. Now, if we build, the library will probably build, but our main program won't. Yeah, that's right. So our error is in main because we're passing the wrong kind of completion. So if we go over to main.rs, this completion, we're going to say, give it a function name, just and define a function for it. In fact, we can just put that way down here. Say function on completion, and then go to our completion type here, copy these arguments. This returns nothing. And this has to be a C function, so we're going to say repr C. Is that right? No, we're going to say, what the heck? No, we're going to say export C. Export C? Extern C. And we're just going to panic here and say completion. Let's see if this is getting called. Check. So under crate, okay, this is, I renamed this to TBC in this module. And that all type checks, lots of unused stuff. I'm gonna go ahead and say allow unused on this program. And then run it. And something panicked. Context.sig init. Panic to do. Okay. This is interesting because it panicked here. So when we called init, this stack trace is very strange. So here's our panic in our completion callback. Let's look at this stack trace. This is all Rust runtime startup called init, tbClient init, tbClient init, and tbClient. Then context.zig, this stack is pointing to return context. I just don't believe this stack trace at all. This is a Rust panic. Let's go look at this context function and see what it does with the completion callback. But I'm very skeptical. This is in context.zig, and this is line 225. So it is saying, the stack trace is pointing here, but really, here it's spawning a thread like we were hypothesizing. And it's got this context here. Context.run. So this thread is running the context, but that stack trace is pointing here. I think this is just wrong. Whatever that stack trace is doing, it seems wrong. And I also want to, I've made a bunch of changes to the Tiger Beetle code. Remember when I uncommented tried to convert the debug logging to info logging? And yeah, I want to undo that because it didn't work. we did panic in the completion callback. And I would really love to see the correct stack trace there, but it doesn't really look right. Let's look at what this init function does with our completion function. Completion function. Puts it on the context. And that's it. On complete, calls the completion function. Who calls on complete? Request calls on complete. Request calls on complete. Cancel calls on complete. Who calls request? Let's look at submit. What is submit? Cancel. So submit can call cancel if you're shutting down. But otherwise, it calls a raw request with the context on result. So the raw request is probably causing the calling context on result. And context on result presumably triggers the completion at some point. User data. Inline operation. On complete. Self.onComplete. This is the context on complete. Batched on completion and function on complete eventually calls the completion function. So it's really kind of disappointing that this stack trace is so wrong. I wonder whose fault that is. Rust is printing this backtrace, I think, since we panicked from Rust. And maybe Rust needed something to happen, because Rust didn't spawn the thread. Zig spawned the thread, and this panic is happening in a different thread. And then it's aborted, core dump, after the panic. Yeah, stack trace looks wrong. Anyway, let's see what's in this completion. So we got a completion, and we can say print line completion. Client is client. Packet. Some of this stuff is not going to print. Timestamp. And the result's going to be the interesting thing, but we're going to have to do some kind of deserialization on this result. Result pointer, result len. This is a string. And we can convert it to a Rust string. So let's go look at the Rust C string functions. And we go to the interwebs. And look at cstir. Cstir is just a reference to a C string. And from bytes until null, no, we don't really need that. Actually, this is not a C string. We got a len. So it's probably a Rust, create a Rust string from it. And get rid of all this. Explanation is empty. It's probably like from raw parts. Oh, it's a slice from raw parts. Oh, this is how we do it anyway. So to get this result pointer and result len, which we assume is a string because it looks like a string, we're going to say let result equals stood slice from raw parts result pointer result len. Let's say let result equals stood stir. I think it's just stir from UTF-8 of result and I'm not on the right scene anymore. Sorry, chat. All right, now you can see my code again. All right, that should give us a string. You can say print line result. And a lot of this is not going to build, but let's see what the compiler says. This len is the wrong size. It doesn't want to just print a plain old pointer to a packet. Let's look at that TB packet again now. I'm wondering if we can debug print that packet, but I don't think we can. So let's just forget about that for now. It doesn't want to print that pointer either. From UTF is not a function. From UTF-8. And this is in the stood. Great. Call to unsafe function from raw parts. Panic. Where's my... Wait. What's panicking here? Chat, what's panicking here? Oh. I bet this panic that I put here is a panic that I was using before in the library. Oh man, chat. Again, every time I change the Zig library, I gotta rebuild it. I think I didn't rebuild it. That's a big foot gun for me right now. And then let's see what this does. Okay, so we didn't get any completion callbacks. Okay, why didn't we get any completion callbacks? In main, we have a completion function, and we pass that to the init function. This packet is an empty packet, so maybe that says like we only get completions for real packets, which would make sense to me because when we looked at the submit function, this was kind of like copying nothing into a message, and then maybe that message, it's a nothing message, so maybe it causes a no-op, so the client never even tries to connect. So maybe this packet has to contain some payload, a request, operation in Tiger Beetle terms. This data needs to be an operation probably. Let's commit what we have and continue on to our next hypothesis. We got to go find an operation to stuff into this data and then hope. So it looks like the client like is very resilient to like bad data, but like a lot of it ends up being like no ops. So we've tried to get the client to do something. And so far the client has kind of said like, oh, you passed us a bunch of nothing. We're doing nothing. I'm giving you no feedback. Which might be reasonable, but it's a little frustrating because we've written quite a bit of code and the client has accepted all the input and given us no feedback. So next I want to go figure out, let's look at the client.zig. Client.zig, no, tbclient.zig. And we have a operation is a state machine operation. Let's get our packet again. TB packet T is up there. Clients C TB client packet So this is our actual packet in Zig. The data is opaque, but the data, I'm sure this data is a pointer to an operation, and the operation is there. So if we look at operation, it's a state machine operation. So where's our state machine? It's inside of state machine. So in Zig, the data types are very flat. And so the types that are used internally to the database also often end up being the types that the clients are sending over the wire. So now we're looking not at the Tiger Beetle client code, but the core state machine code. And these operations are the things that are going to go into packets, presumably. So these operations, or these are the operation numbers. And we have pulse is kind of a no-op. I don't want to send pulse, but we can probably, we want to try to send the easiest operation that we can code up in order to just test stuff. Maybe a lookup seems pretty easy. And so if we again go back to our generated Rust bindings, clebeatline.rs, it's probably something related to TB operation. Right, here's our TB operation type. TB operation lookup accounts. This is the constant we want to set in. So we're going to try to implement a lookup accounts and just see if the client will do that for us. So here we're going to say TBC, TB operation, create accounts, lookup accounts. And this data size, I wonder if this is a constant or if I have to calculate it. Go back to state machine and look, let's go back to tbclient.zig operation state machine operation T is a state machine dot operation state machine operation T. This is just the operation T is just the operation number, but there's has to be like some structs defining all the operations. There has to be. Let's look at tb client dot h. Okay, so here's some structs. Transfer account. TB operation, there's their operation types again. And there's TB, there must be some struct that defines a account lookup. Create account result. TB transfer type. TB account flags. I mean, the TB lookup, account lookup might be so simple that there's not a struct for it. It's data. Let's go back to state machine. State machine operation. VSR operation. Operation from VSR. Turn null. Turns a maybe operation. Event type operation. Okay, so the lookup accounts type is a U128. So there might not even be a struct defined for it. I'm really wondering if there's some kind of like comprehensive place I can look to find the over the wire API here, because I'm kind of struggling to figure out what data should be. But I'm suspecting now that data is a point for lookup accounts. Data is going to be a pointer to a U128. And here's another thing to consider here. I'm calling client submit, and then the main thread is exiting. Probably what I need to do here is I need to block forever on this main thread. So it might be that like I'm missing opportunities to actually see my completions because the program is exiting. Because I think on Linux, the main thread exiting will not, I think it will kill all the other threads, I think. I'm not sure though. Maybe other threads will keep the program alive. But the client here, we'll see. This TB packet is on the heap and it'll be automatically deleted. I'm just wondering what happens when this exits. We need to block here. I actually don't know how to just block from the Rust standard library. Probably read std io std in dot read something. Std in is going to return some kind of result. And say dot read. Let's go look at the docs again. Back to the webs. Std in. And it'll probably just give me one read line that works like this. Just do this. Maybe there's a read char or something. It's going to return a std in. That's going to implement some kind of trait. Std in, you have to take a lock on it. Read line. What does std in implement? Read. I just want to read like a char. Let me read some kind of char. Let's ask ChatGPT. What's the idiomatic way in Rust to read a single char from std in order to block? Oh, yeah, it does that too. So I don't want to create this buffer. I just want to say read me a char. I assume there must be like some kind of read char method. But no, this will work. Ooh. Let's ask that one more question. Is there a read char type method or similar? I don't want to create a buffer. Iterators. These questions look. Ew. Yeah, converted to a byte iterator. Yeah. Okay, that makes some sense. Byte iterator.next, yeah. Std in dot bytes dot next. Gotta use the read trait. My operation, that's interesting. So this operation I put into the packet, this is a TB30, this is a U32. This automatically defined thing is a U32. but this field is a U8, this field of the packet. But I really feel pretty strongly like this is the thing that goes in the field. Let's look at TB operation. So this TB operation in C is just a C enum without a representation. But these are not, okay, yeah, these all fit into a U8. But this enum in C, mostly C says enums are U32s. That's very interesting. Let's look at the, anyway, this is a, I'll just cast this to a U8. That's the correct thing to do, I think. But you would like this to have a U8 representation if this field is going to be a U8. Okay, look at this. It's trying to do something, but it can't connect. And now we're getting some logging. That is great. Let's go back. So this is giving some warning logs, which I like. Maybe before, if you recall, we tried to convert some of the debug logging to info logs, and maybe info is not a high enough log level to be printed by default, but this is printing warning logs, which is great. So note that in the future, we might be able to go back and turn on the logs by converting them to warning logs. Oh, okay. Let's take a second here to just chill and chat. So there's a question in chat. Ippasav asks, are you trying to make the Rust client for Tiger Beetle? And that is what we're trying to do. So my stream is right now about coding up a Rust client for Tiger Beetle. And this is the third stream, and I'm going to be streaming the whole project on Tiger Beetle Twitch. And right now I'm creating Rust bindings to the Zig TB client. And the Zig TB client is a little library that exposes a CFFI used by all of the Tiger Beetle client libraries for every language. And in this stream, I'm just kind of like poking at that TB client library to understand what it is doing and what kind of input it expects, because I don't know how to use it at all. I've not used any Tiger Beetle clients, let alone the underlying C API for the Tiger Beetle client. And in this stream, we've gotten the client initialized. We've submitted a packet, but it was an empty packet, and the client seemed to not really do anything. It was just like, oh, this packet doesn't contain anything. I'm not going to do anything. And we've set up a client callback. So whenever the client handles a packet, we hypothesize that it calls this callback on some other thread. The client seems to boot all of its work to another thread. And right now we haven't received any callbacks because our packet is empty. So at the moment we are attempting to construct a account lookup packet, which is a very simple type of request for the server, and get it to actually submit one of those packets. And just now, one of the problems we've had so far is that all the data we've given to the client has resulted in no ops. So it seems like the client hasn't even attempted to connect to the server. And just now, we've actually gotten some warnings saying, oh, there's no server. So it seems like the client is kind of lazy about connection. Like you initialize the client and the initialize does almost nothing. Like it doesn't actually connect to a server. It's only when the client gets a request that it can actually send that it bothers even finding the server, it seems. So we've just sent it this lookup account operation, and it seems to have tried to connect to the server. Oh, another thing that we've noticed, this is actually might be why it is now doing something useful and printing errors, warnings, because this there's no blocking operation on the client, right? You initialize the client, and then the client creates its own thread and goes off and does its own thing in another thread. And until just now, I was the main thread. I was not realizing what was happening, and I just let the main thread exit. So essentially, I let the client spawn another thread, and then I killed the entire process because the main thread exited. So at this point, I'm saying, nah, main thread, let's just wait for a while, just sit here and let the client go off and do its own thing in another thread. And that's probably why we're now seeing some warning messages, because the client isn't just immediately killed. So let's get back to attempting to build this account lookup operation. And this data is going to contain our packet. And we've hypothesized by looking at the state machine. Look at the state machine, the event types for different operations right here. A lot of the event types have a struct associated with them. Like a create accounts has an account struct. But these two simple lookup operations, they're just U128s corresponding to some account. And so here we got to kind of create a pointer to a U128 account ID. And we probably need to put that on the heap. I mean, in this case, we can put it on the stack and just point to the stack. But in real code, it would probably need to live on the heap and be garbage collected at some point. Yeah, that's right. IPSAV, there's 2 threads involved here, at least 2 threads that we know of. Oh, thank you again. I need a lot of help reminding me to switch OBS scenes. I'm pretty new to streaming, and I very often find that I am just on a different window than the one that I'm actually talking about. So thank you for pointing that out. All right, so here again, let's go to the end of our main function right here. And again, this is all just kind of like prototyping code. It's very ugly code so far. After we submit a packet, the thread it's got to just stop. We just got to block and let the client go off and do its own thing. Before we were just exiting right here, but now we're just waiting for a byte forever. And seems to be fine. I bet if we press the keyboard, we get a byte. Uh-oh. Why doesn't pressing the keyboard read a byte? It doesn't really matter. But here I'm supposed to be, what I'm trying to do is wait for a byte. And here I'm trying to give it a byte, but it's not working. Doesn't matter anyway, because all we're trying to do is block forever. Okay, so we've told it that we have this kind of operation, an account lookup. And we're just create an account on the stack. Let account number equals something that's not 0, so that it has, we have a lot of zeros. At least if we see a 5 somewhere, we'll be like, oh, that's meaningful, not just a 0. This data size is going to be a stud mem size of, I think it's size of, but I'm not sure. Size of U128. And the data is going to be, and again, the API calls for mutable pointers here. I don't really understand why. I know it's not going to mutate the account number. And this mutable REST reference should be coerced immediately to a unsafe pointer. Expected U32 data size. Okay. Size of returns a pointer sized uint, but this API respects U32. We discussed earlier on stream that the Rust as pointers or as casts are kind of unsafe. They're kind of a bad default for Rust. But since we're just writing prototype code, it doesn't matter. We're just going to sloppily cast everything around. Because this usize, that size of returns, might not fit into U32, but in practice it always will in this case. All right, so here we found account number. Data is these. Okay, it's this data is a pointer to all kinds of things, and so in the API they call it a C void. And what we have here is a I don't remember. Okay, 128. So we have to cast it to a unsafe integer and then cast it to just whatever. And we could say underscore here to just make the cast work, but we're going to find this C void. I think it's defined in stud something. We've already imported one C type from Rust. Use, yeah, stud OS raw. It's probably where that lives. And we can say use stud OS raw C void. And then here when we cast this data, it's a star mute C void. And we have to do this intermediate cast to a unsafe pointer. Like if this was the right type, the coercion would just work. But because we need to coerce it to a completely different type, we got to do 2 casts here, I think. Casting star mute I32 as star mute. Why is that an I? Oh, it doesn't know this type. This is an I120, a U128, and it's going to be mutable for some reason that we suspect is not necessary. Okay, so that compiles. And now we have sent it a packet that I think is good. I think this is a valid account lookup account request. I'm going to commit that. And again, I'm just committing garbage commits right now just to checkpoint my work. And now it can't connect to the server. So now we finally get to create a server. So I'm going to go create a database. I have a database here already. You can see this 00 Tiger Beetle. That's how Tiger Beetle databases are named. But for the sake of the stream, I'm just going to recreate a database. I'm going to say zig run format. And this is how you create a new database. And it should tell me this zig, the Tiger Beetle format command should tell me the arguments I need. This is great. We're actually getting somewhere. We might actually talk to the server today. You can see here it said need a replica count. Let's say format replica count equals 1. Need a cluster. Cluster equals 0. It's just a number. And path 00.tigerbeetle. You can hear my voice is giving out. I've been streaming for 3 hours. This is definitely the longest I've streamed, and tired. All right, now it's saying, what am I missing? Replica argument is required. Oh, but look at this. So I say replica equals 1, I think. Maybe it's 0, maybe 0. But then it says unexpected trailing option. So I actually have to put this replica over here. Kind of a little quirk of the Tiger Beetle command line parser. Like it told me like exactly what I needed to do, but then I have to back up and it kind of parsed them in backwards order, which would be a nice thing to fix sometime. And you can see right there we have a database now, and now we can start. And again, it should just tell us the commands we need. Addresses, we can just put that. The path, and that's it. Okay, interesting. Oh, look at that. Can't lock pages in memory. This is a new thing where we lock pages in memory of the actual executable so they don't get swapped out. Probably, yeah, I just have some, this is a VM and R limits are not set correctly. So in production, I think you have to now modify your R limits so that the Tiger Beetle can lock pages, but doesn't affect us. Now let's run our program and see what happens. We got a completion event. Oh my gosh. That was a lot of work, but we're making progress. I'm feeling a little better. And earlier in the stream, my brain was just exploding trying to understand how everything worked at the same time as I was trying to write the code to get it to work. But now we sent it a packet and we got a completion with a timestamp, and the result is nothing. That is interesting. Let's look at our completion function. Result is nothing. We got the context and the packet. So I guess we have to kind of figure out what it was from the packet. So this packet is going to be a pointer to this packet that we made up here. This packet. So to understand what it was, we got to look inside of it and print the operation, I guess. Say, I'm just thinking about like how you actually use this in production. I bet the user data, you got to fill in the user data and then use the user data to kind of figure out what it was you were doing with this packet. We're going to have to go look at the other clients at some point to see exactly what they're doing. Because if that's the case, then the client kind of has this associated context. What is it? Completion context. So every completion is going to get this completion context. And then every packet is going to have its own user data, which we've set to null. And probably in Rust, we're going to be like, this user data is some kind of closure data pointer and construct a closure from the user data. Something like that. Or the user data is a pointer to a closure, perhaps. Something along those lines. All right, we were making a lot of progress, but now I'm kind of seeing how far we have to go, and it's not great because we have no abstraction here. We're just kind of like looking at a bunch of junk, but we've sent a packet. Next thing to do might be to like look at the Go API or something like that and see what their abstraction looks like. Because I'm kind of starting to get it now, but this is not really enough to. I mean, I kind of feel like I get what's going on here. Like in Rust, we need our abstraction to be async and runtime independent. And so in Rust, you're going to submit a thing, and probably internally that thing is going to be waiting on a channel. And when you do the completion, you look at the user data, and the user data probably will contain a channel. Although maybe we'll make it a closure and put the channel in the closure. And you get that callback on some other thread, and then you send something over a channel back to the async Rust so it can handle it in the original thread, probably. You're probably not going to want to expose the fact that the whole thing is happening in some other thread to Rust. You want to make it look like it's all happening within the async runtime that you're currently running in. But I'll probably talk to like King or Alex about what they think the abstraction should be, because I'm kind of getting to the point where I want to go start over and make an abstraction and make this work. And the idea here of like making two abstractions is kind of beyond what I'm feeling capable of yet. Like I was going to say like, here, let's define one trait that can be implemented by both the TB client backend and a pure Rust backend. But I'm really not feeling like I have a full understanding of what needs to happen here in order to design an abstraction that can be implemented two different ways yet. I feel like I kind of need to back up and design one abstraction that works perfectly with TB client. And then after I've implemented that, I'll kind of understand what's necessary to make it work with pure Rust without TB client at all. But I'm kind of feeling like I've accomplished enough for today, and I need to kind of go back and let this stew for a while because, brain hurts, and I've learned a lot, but I haven't really digested it yet. Maybe tomorrow, not later tonight, because brain hurts too much. It's also Thanksgiving. Happy Thanksgiving, y'all. Maybe tomorrow I'll come back with some ideas about how to proceed with a little bit of abstraction here again. Maybe we'll try that idea of making an async interface and having everything call back through well, I got to think about it. Probably talk to King as well. But I think we're probably done for today. I really appreciate everybody hanging out with me for 3 whole hours. and giving me feedback and helping me and encouraging me. That was good practice. And I'm tired and I'm going to go make some dinner for Thanksgiving. And I hope everybody has a really great day. So I'll see you all next time.